The first chapter is about matter. You might all know what matter is actually. So matter is something that has some space, that occupies some space, has some mass, and it is realized by our senses. So basically we can say that matter is something that occupies some amount of space, that means it has a definite volume. Matter has some mass and it can be perceived by our senses. That means we can feel it or realize what matter is. You may not always visualize what matter is, but you can definitely feel or sense what matter is. Everything or every object in this universe, whether it is a living object or a non-living object, is definitely matter. Because any object of this universe definitely occupies some space. That means it has some volume, it has some mass, and it can be realized or perceived by our senses. So matter basically it is comprised of tiny particles, and those particles are called as molecules. So matter is comprised of molecules. Now these molecules can exist independently and freely, and the molecules actually bear the properties of matter. That means the molecules have the properties that will define the matter. So these molecules, they exist freely in nature. So molecules can also be further subdivided into tiny particles, and these tiny particles will be called as atoms. So molecules further are comprised of even tiny particles which are called as atoms. Now these atoms also, they can exist freely in nature, and they can also exist independently in nature. They exist freely and independently in nature. A molecule may be made up of a number of atoms. A molecule which is made up of a single atom is called as monoatomic. Molecules which are made up of two atoms are called as diatomic, and molecules which are made up of more than two atoms are called as polyatomic molecules. So, if you say a monoatomic monoatomic, it means that molecule is made up of a single atom. If you go through the periodic table, you will come across different elements which are actually monoatomic in nature, and those examples are those of inert gases such as helium, neon, argon, krypton. These are all monoatomic molecules. Etc. They are all monoatomic. Diatomic molecule means that it has two atoms. These diatomic molecules are made up of two atoms. Some gases that you will come across like oxygen, hydrogen, nitrogen, they are all diatomic in nature. And if a molecule consists of more than two atoms, it is called as polyatomic. So polyatomic molecules are made up of more than two atoms. You can take the example of different gases like ammonia, NH3, carbon dioxide. These are all polyatomic, you can say. So these molecules, they independently exist in nature and they are made up of more than two atoms. So now, molecules have some basic properties. Those properties are collectively defining the type of matter that is available in this nature. So we should look through all the properties that a molecule possesses. So basic properties of molecules. First of all, they are tiny particles, and so their size is sufficiently small. They have very small size, sufficiently small size. So typically you can say that the size of a molecule is of the order of 10 to the power minus 10 meter. Size is of the order of some 10 to the power minus 10 meter. We assume that the molecules are spherical in shape. These molecules are assumed to be spherical in shape. They are in constant motion, they are not at rest. The molecules are always in motion. Molecules are in continuous random motion. Random motion. What is random motion? Random motion is a motion which is not along a particular direction. The molecules always try to move in all possible directions with all possible velocities. You cannot specify exactly what is the velocity of a molecule at a given instant of time, or you cannot specify the exact direction in which the molecules are moving. They will always try to move in all possible directions that is available to them, and they might have all possible velocities. So this motion is purely random. It is not directed along a specific direction, and this random behavior is something that actually defines the different states of matter also. So molecules are in random motion, and this randomness of the motion is due to a property which is called as the temperature of the material or the temperature of the state of matter. So the randomness of the motion, is governed by the temperature. That means if a given state of matter is relatively hot, then its molecules are more randomly moving, and if a given state of matter is relatively cold, then you can say that its random motion is not very large. It is less randomly moving. And because they are in motion, we say that the molecules possess kinetic energy. So the energy that the molecules possess due to their motion is called as kinetic energy. Molecules possess kinetic energy. Now, kinetic energy is the energy that is due to motion only. You can say that the energy possessed by virtue of motion is called as kinetic energy. The different forms of energy, but we are restricting our discussion to kinetic energy of the molecules. So this is the energy that they possess due to their motion only, by virtue of motion. Now, the molecules are not closely packed necessarily with respect to different states of matter. You can realize that the molecules are not necessarily very closely packed. There is always some space between a pair of molecules, and the space between the molecules is called as intermolecular space. There are spaces between molecules. There are empty spaces or spaces between molecules. And these spaces that is available for molecules to move is called as intermolecular space. Intermolecular space. You might know that matter exists in three states: solid, liquid, and gaseous state. In solid state, the intermolecular space is the least. That means the molecules do not have sufficient space in between them to move from one place to another. So in solids, the intermolecular space is sufficiently small. In liquids, the intermolecular space is definitely greater than that with respect to solids. But in gases, the intermolecular space is the largest. So with respect to the arrangement of molecules, the intermolecular space is least in solids and it is the greatest in gases, and intermediate in case of liquids, you can say. The molecules attract each other with some force also, and that force is called as intermolecular force. There exists a force of attraction. Now, this force is typically an attractive force. There exists a force of attraction between molecules. And this force of attraction is called as intermolecular force. Intermolecular force. Intermolecular force. So definitely in solids, because the intermolecular space is minimum, so the intermolecular force is strongest in solids. That's why the solids possess a definite shape, a definite structure, a definite volume. Intermolecular space is slightly greater in case of liquids, so the intermolecular force as compared to solids is somewhat less in liquids. So liquids, definitely they can flow. They do not have a definite shape, but they have some volume, and they take the shape of the container in which they are kept. As intermolecular space is greatest in gases, the intermolecular force will be least in gases, and so the molecules of a gas are freely moving in all possible directions, and that's why molecules of gas, they more randomly vibrate, they have more kinetic energy, and they do not have a definite shape or size, they do not have a definite volume, they actually occupy the entire space that is available to them. So intermolecular force is strongest in the case of solids, and it is weakest in gases. So intermolecular force is strongest in solids and it is least or weakest, you can say, weakest in gases. Whereas intermolecular space is least in solids and greatest in gases. Now, on the basis of intermolecular force, we can define what is called as cohesive and adhesive force also. Remember that this intermolecular force is a force of attraction, it is never repulsive force, and this force does not depend upon the mass of the molecule, it does not depend upon the charge of the molecule also. It is totally independent of mass and independent of charge. It is a purely attractive force that depends upon the structure of the molecule itself. So you should remember that this intermolecular force is independent of mass. Independent of mass, it is independent of charge, but intermolecular force is always an attractive force, and the intermolecular force exists within a particular distance. The intermolecular force, the range of the intermolecular force is approximately 10 to the power minus 9 meter, you can say. So if the separation between molecules increases beyond 10 to the power minus 9 meter, then there is no existence of intermolecular force. So the intermolecular force, range of the force, you can say the range of the force is approximately of the order of 10 to the power minus 9 meter. So if the separation between the molecules exceeds this barrier, then definitely the intermolecular force goes weaker and weaker, and ultimately it does not exist anymore. So it is a strong attractive force that exists when the intermolecular separation or the separation between the molecules is nearly 10 to the power minus 9 meter. So on the basis of intermolecular force, we can also define what is called as cohesive force and adhesive force. So between molecules, the intermolecular force will be cohesive in nature if the molecules are exactly identical in all respects. That means between the molecules of a definite type of matter or definite type of material, the force that exists is called as the cohesive force. So you can say that attractive force between similar molecules is cohesive force. For example, the force of attraction between the molecules of water, force of attraction between water molecules or between any type of molecules of the matter itself. Force of attraction between water molecules is an example of cohesive force. Now these intermolecular force are also adhesive in nature. Now adhesive means it is the intermolecular force between different type of molecules. So it is an attractive force, you can say, between dissimilar molecules. Dissimilar molecules. Molecules of different type. Between molecules of different type, the force of attraction is called as adhesive force. For example, if you pour some water in a glass and then remove that water, you will see that some water droplets will stick to the surface of glass. So it is the adhesive force between the water molecules and the glass molecules, due to which the water molecules stick to the surface of glass. There are different properties of liquids which can be discussed or explained on the basis of this adhesive force, which we will learn in higher classes. And those properties are the property of surface tension, viscosity, etc. We need not discuss this because it is much beyond the scope of our syllabus. But still, for just a basic example, water molecules, you can say, stick to the surface of glass. Due to adhesive force. So it is the force of attraction between the water molecules and the glass molecules, due to which the force of adhesion arises.